Hello, welcome back. So it's my pleasure to be here today to share experience with friends and participants in this workshop. I present my topic on soil fungal community under eucalyptus plantation in Ethiopia, just as evidence for evidence-based management planning in forest management, especially in plantation development. So here it's a collaborative project where we have people from University of Valladolid here and Ethiopia Forest Development and myself. So to start with some historical background of eucalyptus in Ethiopia. So it's exotic species is introduced to Ethiopia like 130 years ago, and just mainly during this time it's introduced as a solution for solving fuel wood shortage, especially in the capital cities because of limited native species, or maybe to solve problem of deforestation. Today, this eucalyptus plantation cover over 1 million hectares of land, approximately 1% of the total forest cover. And in Ethiopia, the total forest cover around 23.6% as of 2023 Forest Development Report. And so from here you can see the total land area of Ethiopia is estimated to be like 1.1 million square kilometer. So from socio-economic perspective, eucalyptus is used for different purposes, like for construction purposes as scaffolding or supportive materials, and also for as a fuel wood, and also for different issues. Apart from this, there are eucalyptus dilemmas or critics over the century because of eucalyptus said to be nutrient drain up, it consumes too much of water, it competes with other native species or biodiversities. So these stakeholders, especially from growers, as you see in these triangles, like the growers are positively accepting or maybe appreciating from its diverse perspective or economic incentives, because it is rotation period is very short, so that they can get income from the sale of this eucalyptus plantation, whereas researchers are questioning to have evidence-based planning of this eucalyptus plantation in the country, whereas environmentalists are against maybe the expansion of this eucalyptus plantation in the country, because it's compete with the native species, it drains up water and the spring and the likes. So as our interest is to, as researchers, to support evidence or to provide evidence for decision makers, and to support maybe whether we have to enhance eucalyptus plantation in the country or reduce maybe the eucalyptus plantation from the soil biodiversity perspectives. Because these issues are mostly the issues like competing with soil nutrient, competing with water is more or less related with the soil biodiversity issues. So we are in our study, we plan to or aim to address, answer these questions, these objectives, like to identify soil fungal diversity associated with two dominant or widely used eucalyptus species, mainly the Eucalyptus globulus and Eucalyptus camerulensis, and also to analyze and compare the composition of soil fungal taxa in areas planted with these two dominant species, and also to investigate the effect of these eucalyptus species and associated environmental variables in soil fungal community composition. So as a method, we employed ecological sampling where these two species are dominated in the country across 8 sites, where these two species are widely used in order to have a representative data. So we collected soil sampling under these two Eucalyptus globulus and Eucalyptus camadulensis, and we carry out fungal metagenomic analysis here in ID forest. So when I come to the key findings from this study, we found nearly around 4,000 fungal taxa. As you see maybe in these chrono charts, I'm sorry to say, maybe this, just enjoy with the slides, it's not the different taxas or maybe the names, but this is to show how abundant these eucalyptus plantations in terms of soil fungal communities. So when I came to the first objective, effect of eucalyptus species on abundance and diversity of soil fungal taxa, we observed it from the sampled soil analysis, and no significant effect of is found when we see the two species. So in terms of richness, Shannon index, and evenness and relative abundance of the recorded species, no difference between the two species is observed. Of course, this is interesting because our aim is to contribute for evidence-based management of this eucalyptus plantation, as long as the ecology allows for planting maybe these eucalyptus plantations. Maybe the landowners or growers can complementarily plant maybe in a given landscape, suppose the species. And also when we see the second objective in relation to the soil fungal composition in terms of soil fungal taxa, again we didn't observe the difference in between these two species. And also what is interesting here is we found a different soil fungal taxas in the stated site under this eucalyptus plantation. When it comes to the effect of these eucalyptus plantations, species and associated environmental variables influencing the soil fungal community, we observed a significant effect of eucalyptus species in terms of at community level, and also different soil environmental variables like elevation, latitude, the location of the site or the plantation site, as well as mean annual precipitation, some selected soil properties correlated with the soil fungal communities, as well as also with the soil fungal, the fungal guilds. So from overall, to find out or to determine which of the fungal species are specifically contributing in line with these two major species. So when we see those 3,000 over 3,000 species, the Eucalyptus globulus accounts maybe for higher, I would say, higher species, and the Eucalyptus camadulensis also have significant amount of these fungal taxas. And importantly, both species also share in common some species, or of course as large number. And this species on the left side, maybe when you see with that's of Eucalyptus globulus, among the key indicator species, we found around 40 species are statistically found as indicator in these Eucalyptus globulus related, and whereas around 137 fungal species are found to be as significant species in relation to these Eucalyptus camadulensis. As to the key conclusion or takeaways from these findings, so these results could provide insight into how the plantation of different eucalyptus species impacts soil fungal communities and soil health. And also this understanding this fungal association may also help inform strategies for enhancing the different types of ectomycorrhizal species and soil nutrient cycling in managed plantation forest. And finally, planting different eucalyptus species in separate sites and combining them at a landscape level enhances soil fungal richness and soil biodiversity. Thank you very much. This is all my presentation.